Mass-to-mass conversions. Whenever you are given the mass of a substance and asked to find the mass of another substance, you must do a mass-to-mass conversion. In this type of conversion, you will be using mole ratios and molar mass ratios. So let's review them a little bit. Molar mass ratios. You can write molar mass as a ratio to use in conversions. For example, by looking at the periodic table, I can find that the molar mass of carbon is 12.011 grams per mole. We can write this in two different ways. First of all, we can put 12.011 grams on top and divide it by 1 mole, or if we need to, we can put 1 mole on top and divide it by 12.011 grams. You'll also be using mole ratios. You get mole ratios by looking at the coefficients of the balanced chemical equation. For example, in this chemical equation, we have hydrogen plus oxygen producing water. When we balance that, we know that we need to have 2 hydrogens, 1 oxygen, and 2 waters to produce, to be able to balance the equation. So a mole ratio of hydrogen to water would be 2 moles of hydrogen to 2 moles of water. Steps for solving mass-to-mass conversions. Mass-to-mass conversions are a multi-step process, so you must use this format in order to obtain your answer. So first of all, you're going to balance the chemical equation. Then you are going to start by listing what you are given. You're always going to be given the mass of the substance in grams. So you're going to list that. Then you're going to use that substance molar mass to convert to moles of that substance. Remember that you're going to put moles on top and grams on bottom to be able to cancel out those grams. So once you would multiply and divide here, you're going to end up with moles of the substance given. But we are looking for moles of a different, mass of a different substance. So we're going to use a mole ratio to convert from moles of substance given to moles of the substance that we're solving for. Once we multiply and divide, we will end up with moles of the substance that we're solving for. So then we're going to use that substance's molar mass to convert to the mass of the substance that we're solving for. In this example, you're going to be putting grams on the top and moles on the bottom. Let's take a look at an example. If the equation for the formation of water is 2H2 plus O2 produces 2H2O, how many grams of water are produced from 2 grams of hydrogen gas? So I'm just going to set it up like I showed you. First of all, I'm going to list what I'm given. I'm given 2 grams of H2, which is right here. I'm going to use the molar mass of H2 to convert to moles of H2. So I know that the molar mass of H2, by looking at the periodic table and adding 2 hydrogens together, is 2.016. I put moles on top because that's what I'm looking for. So I would actually multiply and divide here, or I could just set it all up and multiply and divide across. So then I'm going to use a mole ratio of moles of the water, because that's what I'm looking for, divided by the moles of what I'm trying to get rid of or what I'm given. So according to the chemical equation, I have 2 moles of water and 2 moles of hydrogen. Then I'm going to use the molar mass of water to convert to grams of water. In this case, I put the mole on the bottom and the grams on the top. I multiply and divide so you can see that my units are canceling. So grams of H2 divided by grams of H2 cancel. Moles of H2 divided by moles of H2 cancel. Moles of H2O divided by moles of H2O cancel. So now I'm left with grams of H2O, which is what it's asking me to find. I multiply 2 times 1 times 2 times 18.015, and I divided by 2.016 times 2 times 1. Well, if I do that using my calculator, I find that I have 17.108 grams of water produced. All right, well, that's it for mass-to-mass conversions. Go ahead and click on one of the other types of conversions to learn more.